Well, hello everyone. My name is Patrick. I'm a PhD student here at Dalhousie in Dr. Travis Esau's Agricultural Mechanized Systems Lab. I deal a lot with machine vision and machine learning for agriculture and their applications in precision agriculture. Specifically, I work a lot with wild blueberries. This is a crop that grows in northeastern North America, Nova Scotia, New Brunswick, PEI, Quebec, and the state of Maine down in the United States. They sort of grow on abandoned farmland and then the deforested areas. They grow naturally and they just kind of take over the land if the land is left unmanaged. And then we kind of help them grow a bit more to improve crop yields. On the left here, you see what a typical field in Nova Scotia might look like. It's just, it's not a square flat field. It's lots of hills, irregular shape. And on the right-hand side, we can see the ripe crop ready to be harvested. Now, this crop is really important to us economically. It's worth about $100 million a year in our province alone, and we only have about 1 million people. So there's a huge economic impact. So we want to do things that are going to help maximize its potential. And one of the problems here are weeds. Two of the species that we see in blueberry fields are on the screen now, sheep sorrel and hair fescue. So these weeds compete with the crop for nutrients in the soil. They can grow taller than the blueberry plants, which block out sunlight. And then they can actually interfere with the harvesting equipment. They can get things clogged up in the system. Some other management practices like tillage, for instance, doesn't really work in wild blueberry fields because the plants grow there naturally. We don't have these growing in rows. They just kind of grow everywhere. So we have to use liquid herbicide applications to suppress these weeds. In addition, when it comes time to harvest, it's a very manual process. Although we have a machine, which is a harvester, it's an attachment to any standard tractor. We have a picking head, which is carried on the side, which goes through the blueberry vines and pulls the fruit off. Then it goes up a conveyor belt into yellow or orange boxes on the back. Now, if you look at the operator in this picture, he's not actually looking in front of him to see where he's driving. He's actually looking at the picking head. And the reason for that is that the blueberries themselves can grow at a lot of different heights depending on their clonal variety. So they can be 5 centimeters off the ground or they can be 30 centimeters off the ground. And the height of that picking head has to be continually adjusted by the operator while they're driving the tractor. So this is a really manually intensive process. Meanwhile, they have to look in front of them to make sure they're not, running over something, and actually looking behind them to make sure the bin isn't being overfilled. So what we want to do is develop some things that can help grow the crops better and make them easier to harvest. And with that, we use a combination of machine learning and machine vision. So machine learning is a subset of artificial intelligence, which is really how computers can automatically solve problems that typically require human intelligence. A subset of machine learning is called deep learning, where we use artificial neurons, which are mathematically laid out in a way that's similar to the neurons in our brains, and those can be used to make decisions. For vision applications, for instance, we can put cameras on the sprayer. So this is a standard sprayer and it has nozzles that are pointed down towards the ground of the blueberry fields. These cameras are taking images in real time and processing them through a deep learning algorithm. So what we did is we captured many pictures of wild blueberry fields. The first algorithm we did had about 4,000 pictures, and then we labeled the coordinates of weed instances. So here's a picture with some tufts of hair fescue, which was the weed that I showed earlier. They're labeled, and we have a corresponding text document which has the coordinates of where these are. And then we can feed these into the computer over and over and over again. And then our deep learning algorithm can then take new pictures or video and pick out where those weeds are. So if there's a weed in the loop that is picked up by the camera, it can send a signal to the sprayer to spray herbicide directly on that weed. And if there aren't any weeds in that section of the field, well, then the nozzles stay turned off. We don't spray any product, which is better for our environment and better for profitability. Additionally, there's a lot of different species of weeds in wild blueberry fields. There's more than 200 unique ones as of the last survey. So one of the other important aspects is actually getting the right herbicide to spray for a particular field. There are some experts in the area that can help with that. But overall, there are a lot of small farmers that might not have the time or the money to wait to bring in an expert to help them with weed identification. So we can use these same algorithms to help them with that and give them suggestions for what that weed might be. Here's an example of an online app that runs, in the web browser of your phone. So the grower can take a picture of what weeds they see in their fields, and this app can give them a recommendation for what it thinks that weed is, and then links to professional documentation from our provincial governments or from universities on what's the best practice for getting rid of it. Another application of this vision technology is looking for the right crops. So we actually originally used this as a yield prediction model, looking and counting the ripe berries and unripe berries to see, what the yield is before we harvest. However, we paired this with a 3D camera. I mentioned earlier that the harvester operator has to continually watch where the berries are and move the head up and down to match the height of the crop. With this camera, we were able to localize the location of these berries, in 3D. So we picked them up with a deep learning algorithm. We used the stereo vision to figure out the 3D position, and then we were automatically setting the head height, which took the stress off of the operator. The operator was actually able to just drive, and in our testing, only had to intervene once when the harvester head was going to hit a rock rather than stay on the ground. So we saw similar efficiency at picking the yields using this automatic system based on machine vision. And we actually lowered the operator's stress indicators like breathing rate and heart rate. So this should lead to an easier time for the operator and hopefully a safer working environment and a more efficient working environment. So those are just some applications of machine vision here in the wild blueberry industry that can be applied in a plethora of crops. I'd like to thank our funding partners and the research teams that we work with on this research. Thank you very much, and I'll take any questions you might have.